Hello, my name is Calvin Perumalla, and I am a postdoctoral researcher from the Technology-Enabled Clinical Improvement Center, or the Techie Center. And today I wanted to share an AI-based method to identify basic surgical maneuvers in surgical videos. Video-based review of surgical procedures has been found to be useful in characterizing surgeon skill, which has then been shown to be associated with outcomes. As a result of that, there has been an effort to build AI based algorithms that are able to automatically identify the procedural steps of a given video. Um, this is done in order to facilitate ease of review, since the raters who review these videos are able to directly view the critical procedural steps that can better showcase skill. However, some operations are more complex than others and may require additional steps to be performed by the surgeon as a safety measure or to correct errors that may have happened during the course of the surgery. The presence of basic maneuvers such as suture throwing, knot tying, and suture cutting in certain procedural steps can indicate error management activity or safety measures and allow for important analysis of procedural outcomes and surgical skill. So we hypothesize that we can design and test a deep learning algorithm that is able to identify the basic maneuvers, which are suture throwing, knot tying, and suture cutting. So the data set that we used was originally captured at the annual conference of the American College of Surgeons in 2019, which was held in San Francisco. More than 200 surgeons participated. The participants were asked to perform a simulated bowel enterotomy repair. A leak test was performed by perfusing liquid through the bowel and observing any leaks from the bowel tissue. Participants whose repairs did not leak were considered to have a successful outcome. The procedure was captured in video. Of these 200 videos, 56 videos were viewed and annotated to mark the time windows where the basic surgical maneuvers were performed. So we then cut these videos into 2-second clips for ease of processing, and the frames for each of these videos were downsampled and fed into a convolutional neural network, and specifically a ResNet 50 architecture, which is a popular image recognition algorithm. The pre-trained ResNet 50 model was used in order to extract meaningful visual features from the provided frames. These visual features were then fed into an LSTM. The LSTM structure is able to capture sequential relationships in a given clip, capturing the inherent differences in gestures associated with each of the basic maneuvers. The model can therefore output a prediction of what maneuvers were being performed in any given clip. So when it comes to results, the overall accuracy was 84%. The model was able to detect throws and knot ties with a precision of over 80%, and was able to detect suture cutting with a decent precision of 90%. In the future, we hope to see these methods incorporated into video segmentation protocols. The bottom figure in the middle column shows a mock-up of a video-based tool integrated with our described technology as it may appear on a rater's computer. So here it is showing an open colectomy procedure. The time points are generated by an AI algorithm and indicate the procedural steps. For example, if the rater wishes to only view the portion of the surgery where the dissection was performed without watching the entire procedure, they can do so by clicking on the rightmost box on the bottom of the screen. So the blue time points show steps where error management measures have been taken, where suturing and knot tying is used to address inadvertent bleeding. The orange points show steps where suturing and knot tying is used to reinforce the tissue. In evaluating the skill of the surgeon, it may be important to view these error management clips to understand the context of the error. In conclusion, I just want to reiterate these points. Identification of basic maneuvers in certain procedural steps can allow for superior analysis of outcomes and skill. Current video segmentation protocols only focus on procedure steps in video-based review. A deep learning model was trained and tested to show moderate accuracy in detecting basic maneuvers. Basic maneuver detection models such as the one presented can be used to complement existing protocols for enhanced analyses. For future direction, this model can be further fine-tuned to recognize when no basic maneuvers are being performed at a given time. And the study can also be performed to quantitatively measure the significance of an AI-based maneuver detection like ours on training efficacy. Thank you very much.